The Physics of Sound and Music with Doc. Here we're going to look for formulas for the first exam. A student has requested that we find all the formulas that we need to know for the first exam. First exam covers A through G, so we're going to go to the download page and we're going to look for the PDF files. These are our chapters, and find chapter A first and go cruising for formulas. So I'm going to look for something that involves parameters and they're related with an equal sign. That's what a formula is. So we're looking for like letters, combination of letters, and an equal sign. Our first formula is found in chapter A, involving the measurement of the speed of sound. And here we have an equation that relates some parameters. It relates the velocity or the speed with distance and time. This is a general formula and it can be applied to anything that's moving. For example, the speed of a car is equal to the distance the car travels divided by the time of the trip. So if we go 250 miles in 5 hours, our speed is 50 miles per hour. And that would be an average speed, because you might stop the car and do something else and travel at different speeds when you pass a car. But on the average, you would be traveling at 50 miles per hour. So the formula is the velocity v is equal to distance d divided by time lowercase t. We will reserve uppercase T for the period of a wave. And you could also write that formula as d, lowercase d, is equal to lowercase v times lowercase t. In other words, the distance is equal to the velocity times the time. You really only need to remember your favorite form, because you can get the other variations from the form that you are most comfortable with. Looks like that is it for the formulas in chapter A. Simple harmonic motion, no formulas. And remember, a formula has symbols and an equal sign to relate parameters. And that's what we're looking for, the formulas. Here we have oscillations, and we have a formula. Here's one. The period, uppercase T, is equal to 1 over f. So the period is 1 over the frequency, which we can also write as the frequency is 1 over the period. Once again, a formula here has more than one form, or it has variations. In this case, there's only 2 variations. When you have 3 parameters like the velocity, distance, and time, you would have an additional variation in there. And let's see what else we have here. Looks like waveforms, no equations, no more equations. I think with resonance here we are finished. Chapter B. Chapter C is next, and this would be waves. And big formula. Here we go. Here's one. We have letters, parameters, and an equal sign. The speed of a wave, or the velocity, we use velocity and speed interchangeably. The velocity is equal to the wavelength times the frequency. If you happen to know a physics major, may take issue with that and say velocity technically is your speed plus a direction, but in this case we're not going to worry about that detail. All right, so we have what else? It looks like no more formulas here. Now you have certain things where you add waves. You have manipulations involving math, but we're interested in formulas here, where we have parameters that are related with an equal sign. So we move on to class D, and for class D we have our first repeat. The sonar problem is a repeat of using the formula distance is equal to velocity times time. Here your velocity is 1500 meters per second, and there's a time involved and a distance. Always be careful when you have a distance and time. If you're doing a round trip, you're getting the distance of the round trip, and if you want only the depth of the lake, you have to divide by 2. Just like if you had a round trip to Hickory and that came out to be 150 miles, but you wanted to know how far Hickory is, you have to divide by 2 to get 75. We move along and see that we have another repeat. Here is a repeat. The velocity is equal to the wavelength times the frequency. In this case, we took the wavelength to be 1/10 the size of dinner and used that same formula. So that's nice to have repetition and applications. These formulas are very powerful. The Doppler effect here is next, and wave addition. Oh, beats. Beats, there's formulas here. For the beats, we have, let's go down here and find 2 formulas. For the beats, you have the formula for the frequency you hear and the pulsation frequency, the beat frequency. Now, remember that 2 similar tones, these tones have similar frequencies, almost the same. They're very, very close. That's important for beats, that the frequencies are close. And for the frequency of the tone that you hear, you take the average. And for the pulsations, the loud soft variation, see those pulsations, that's the difference. So the tone, the pitch, the frequency you hear as a pitch is given by the average, and the beat frequency refers to the pulsation frequency, and that's given by the difference. That's all for that chapter. And if we go to chapter E involves modulation, and there are no formulas in this chapter. And by formula we mean letters that relate with an equal sign, parameters that are related. So we're going to chapter F, and for chapter F, I see ratios, intervals are here, and you have Lissajous figures. We'll have a separate review on Lissajous figures for you and some other topics. But no formula that has letters that relates those letters. It looks like nothing here. Ratio calculations, but not a formula with variables, and that's what we're looking at here. And I'll show you, how to do things like this in other tutorials. Here we're just looking for formal formulas. So here we go to G, and G will have formulas. If we go to G, to the summary table of the chapter, here we go. We have a formula for the frequencies of the various harmonics and a formula for the wavelengths. The formula for frequencies of the frequencies, very easy. It's simply the number, the case you're looking at, say case 6, it's 6 times the first one. And the 7th case would have the frequency 7f. So you can think of this as if n is this number, lowercase n is one of these numbers, then just take n times f, where f is the first one. So the frequency for the 73rd one, n is 73, the answer is 73f. For the wavelength, you take 2L and divide by the case that you're looking at. So if I'm looking at the 7th case, it's 2L over 7. The 8th case, 2L over 8. So there are 2 powerful formulas, one that gives you this column, the wavelength column, and one that gives you the frequency column. And that is the last formula for the exam. And we'll go over things like these intervals in another review.